Good morning, everyone. My name is Glenn. I'm with the County of Sonoma. I'm the Integrated Waste Operations Division Manager for the county. My background is as a geologist and hydrogeologist in the state of California, performing environmental cleanups and remediation type work. Next slide, please. So today I'm going to talk a little bit about the cleanup process when a site structure is burned during a wildfire, and noting in this that every fire is going to be different. Different counties, cities, states may have different criteria that are put in place. So let's proceed. Next slide, please. So in 2017, Sonoma County had really its first encounter with wildfires. We had the Pocket, the Tubbs, the Nuns. In the adjoining county, there was the Atlas fire over in Napa. Next slide, please. So for the Tubbs fire, 36,000 acres burned, 6,500 buildings destroyed across the county and cities, quite devastating. And 5% of the housing stock was lost in that event. Next slide. So, not hard to imagine is there's a large cleanup process involved when that many structures are impacted. And the first phase of that occurred in 2017 was a hazardous waste removal from the sites. And this involved removing the most toxic of the fire debris at a home site, batteries, paint, car parts, asbestos, heavy metals, PCBs, all those things that are really, really difficult for your average contractor to take care of. And in this case, it was performed by US EPA. In fires that preceded this, it's DTSC stepped in, a different specialists have stepped in to perform that. Next slide, please. The second phase of cleanup is the actual removal of visible ash and transporting to a landfill facility. In this case, typically what was performed in 2017 was removal of the top 3 to 6 inches, after the removal of visible ash, 3 to 6 inches of soil was removed from the impacted area, and it was removed to a level of visually clean. And Sonoma County implemented a Cal recycle protocol in this, where the material is wetted and loaded and what we call burrito wrapped in a vehicle, so none of that material flies out of the vehicle going to the solid waste facility. And it also the wetting serves as a protective measure for site workers that ash isn't thrown up while they're loading it, and so they're not inhaling it or taking it in, which is a noted health hazard. Next slide, please. So in 2017, the county tracked this electronically to where we could easily see that a first phase of contamination was removed, and then consequently the second phase where the ash and dirt was removed to a level of visually clean. Next slide, please. So when cleaning up a burned structure, there were several criteria that were put into place that we looked at. We had to take into consideration constituents of concern, and whether dioxins, furans, heavy metals. We had to look at health screening levels, and we also had to look at health screening levels versus background condition. And in this case, it's been mentioned before, but metals were used as marker indicators for this. And then lastly, we're just going to talk about how background was established for cleaning up these sites. Next slide. So as mentioned, constituents of concern for a fire, dioxins and furans, typically that's in an impartial burn. Those constituents can be formed, metals, PCBs, VOCs, hydrocarbons. And really, if you think about your own home where you might live, there's many things that anything that you have in your house, whether it's electronics or lead acid batteries, they all, after a fire, can serve as a source of contamination in soil. Next slide. So marker indicators. So even though there can be many, many constituents that are left after a fire that are of concern, um, many of these can be very costly to analyze for. And for some of the exotics like dioxins and furans, there's only a limited number of labs in the whole country that can actually test for them. So what the county did was implement an existing program that Cal Recycle had, where heavy metals were utilized as a marker indicator. So if the heavy metals were removed to background condition and they met health screening levels, then by virtue of that, the presumption was that all other constituents that we might be concerned about were also gone. Next slide. So in establishing health screening levels, the county looked to utilize through Cal Recycle protocol, US EPA risk-based screening levels, California Environmental Protection Agency screening levels, and DTSC Office and Health and Ecological Risk Assessment levels. Next slide. So these screening levels were only applied when they were higher than, it's important to note, higher than identified background condition in underlying local soils and formations of the burn footprint. So as a general background, there are naturally occurring metals in soils throughout Sonoma County. In fact, most of the state, if not, any soil out there. And in some cases, those levels are actually higher than health screening levels. So when we look at metals remaining after a burn site, where background conditions are deemed higher than published health screening levels, home sites can still be cleared when the results of tests are within 20% of the background data set, despite exceeding published health screening guidelines. And that's just a fact of the world where we live. There will be naturally occurring metals that will exceed health screening levels where you live. And the best example of that in Sonoma County is arsenic, where it typically exceeds health screening levels in most soils. Next screen. So, the establishment of background conditions are based on numerous factors. First, it's based on local geology. Different formations will have different concentrations of metals in soil. It can be set up, background conditions can be set up based on either a statistical model over a large area, or it can be site specific. Statistical models are more useful during larger events where destruction of property has occurred in mass, and it generally results in less cost to property owners and for the cleanup in and of itself. Site-specific models are implemented on a much smaller scale, and by virtue of that, they're more accurate, but at the same time can be more costly. Next slide. So in 2017, for the public program and cleanup of impacted sites, background data sets were collected by Tetra Tech for the different fires. And what you're looking at here is the Sonoma Valley Fire Incident Map. And you will see that a number of background locations were sampled to look at metals in native soils. So quaternary alluvium, Sonoma volcanics, ultramafic formations, and they're basically soil types derived from different geologic formations. So next slide. So once this background data set's established from multiple samples, you'll notice the first column is background data. So for Sonoma County, Tubbs Fire Incident, and the Sonoma Volcanics, which is represented by TV, there are background metal concentrations. And to the right of that, you'll notice that we have all the screening levels that were identified earlier: Cal EPA screening levels, DTSC HERO screening levels, and US EPA residential screening levels. And you'll notice I have arsenic circled there and a cleanup goal on the right. So let's go to the next screen, please. So in this case, in establishing a cleanup goal, even though our most conservative our most conservative health screening goal, the DTSC HERO goal, is 0.07 milligrams per kilogram in soil, native background of arsenic is running at 7.2. So in this case, the cleanup goal was established at 7.2 milligrams per kilogram. Now, antimony, we took the lowest level, which in this case was the Cal EPA screening level of 30 milligrams per liter, and hence the cleanup goal was set at 30 for that analyte. Next slide, please. So after a site's been visibly cleaned, confirmation samples are collected, generally by a licensed professional, and after all fire-related debris has been removed from the property. So in this case, the representative samples are collected to determine basically compliance with the cleanup goals established either by state or federal government and available at the health department. And the total number of samples that are collected are going to be based on the estimated square footage of the ash footprint. The basic goal is to grid a site and get representative samples of the area that was impacted. Next slide. So in this case, if you had a structure that was under 100 square feet, you would take what we would call a 5-point aliquot, which basically means you grid out like a dice, number 5 on a dice, and you grab 5 samples, evenly spread across the area impacted, and you throw them into one composite sample and you send it to the lab and test for it. If you have a larger structure that is up to 2,000 square feet, you would take 4 of these composite samples gridded across the site to represent the footprint that was impacted. And you would compare these analytical results that come back against those health screening levels established by the health department. Next slide. So once soil is found to meet the criteria that you've removed to the cleanup goal criteria of removing ash and impacted soil, the site's cleared for rebuilding. And post cleanup, soil property owners may wish to get that data. Typically, if you participated either in a private cleanup or a governmental cleanup, you're provided a copy of the soil testing data after site clearance. So you should be able to see that the site met the cleanup goals and also have an idea of what concentrations of metals are on soil relative to your property. For real estate transaction, this data should be disclosed and available to new homeowners. Now, if you're buying a property, or if you were unfortunate enough that your property, you lost your property, which I'm very sorry if that has occurred with you, and you did not get this data, you can contact your local health department, and they should be able to provide you a copy of the site clearance records for your property.